Hey everyone, so okay, checking out, you got my computer right down here, and that's the mill. Obviously, I'm way too close, and we've got backlighting. Great. So I'm going to move this whole apparatus you're a part of over, and maybe that will make things better. Yeah, okay. You know,
They're going to legs. I knew they were coming out. How are you?
good.
They left you all alone.
They did leave me alone.
Why?
Because they do that.
Well, Nikki been left you. I seen Nikki when I was at the beginning of my route.
Do what?
I seen Nikki at the beginning of my route.
Yeah. So I'm live on the YouTubes. That's okay. That's my mail lady. I love her.
I'm awesome.
Uh-huh. Be good. So, it'd probably help if I blocked off that light coming in through the windows. Yeah. I've got bunches of cardboard. Maybe we'll do that in a bit if it stays bad. So this is a vertical milling machine. It's a copy of like the Bridgeports that are, they were the original machine that could replicate itself. I'm college educated. I was a Navy electronics technician, and I've never had any formal training on a vertical mill or machining. All of my knowledge has been, like most things, learned the hard way. So the first disclaimer about it, if you know better than me, that's fantastic. You're not here contributing. You are welcome to provide a link to your video which does it better. Violators of this rule will be chastised, roasted, and made fun of in some compilation later. Okay, so let's see if we can move you back. I apologize for how loud that might be. All right, so the fundamental components is you've got a three-phase motor at the top. You have the head. Usually, older machines are going to have a series of pulleys and belts, and you're going to throw a lever to loosen the belt and change the speed like an old drill press. Yeah, you're just going to want to go find like a wiki for the names of all this. But this is like your drill press arm. It makes it go up and down. The mill kind of special is that it's so rigid. It is so strong. It is just incredibly stiff, and it's great. Let me see if this light here, hanging on the side, maybe that'll help. Oh, it just goes to there. All right, that's fine. Gimme, gimme. And of course, there's nothing to put this on. That's fine. We're prepared. So there's a few kind of crazy things about mills that, maybe will catch you off guard a little bit. Don't ever count on forward or reverse. That just means one direction or the beginning of the gearbox has a high and a low speed. So when you're in one or the other, it changes direction. So forward reverse only matters for that speed. So yeah, you've got your power here, and then for the spindle. So that's something that drill presses won't have. This lets you stop. And so what I'm going to do is show you the drawbar. I don't even know if I've ever had the drawbar out of this. There we go. I've never even had this out. So you've got a bar that goes through the whole spindle, it's threaded at the end, and it pulls. It's called an R8 collet. The R8 taper is basically, put my head in the light, it's this here. You have groove cut in it. There's a pin locating on the shaft. So you have to turn until you find the pin, and then you can push up and you tighten the drawbar. So this is just a manual chuck. I use this for drilling and tapping a whole lot. I won't necessarily go to this first for drilling or other work because this is going to be less rigid than if you put your tool directly into a collet. Plus, if you just tighten this by hand, it's not that strong. And then if you put something in it and then you tighten it with its spanner wrench, now you've got the better chance of breaking the tool that's in it rather than it just spinning. I'm really great at breaking stuff. So like I've learned lots of ways to not break things. So this is a mess. It's a fantastic mess because I never take the time to clean things up. I don't ever do things the right way. And so, yeah, sorry about that. Sorry about your luck. So if you're going to want to do something on your mill, you're probably going to want to get some end mills. So pretty much everything you could just get the kind of lots of decent rating reviews, starred stuff from that Jungle website. And so I bought a collet set that goes up in 16, maybe. I don't even know. Maybe eighths? Probably eighths. No, it goes up in 16s because I've got 9/16 or 5/16. So it goes up in 16s. And a lot of times when I use my mill, it's to do kind of quickie prototyping, or I want to adapt something to something else. Like most of my machining is like in that class of prototyping or stuff like that. So kind of I use it to put holes where I want them. Sort of like a specialized drill press. If I need to make something lower and deck it or make it flat, okay, sure. You know, you can do that. I don't necessarily do a whole lot of big projects because normally if it's that crazy, I 3D print it or I send it to a machine shop for them to do once I've figured out sort of what's up. So, probably what you'd want to do is get some larger, if you're going to be working with aluminum, you want to get a few larger end mills, say 3/4 to 7/8, 1 inch. You can get a set, and then you can use, like, say, the 3/4 one for most of the hogging and abuse, and then that way you kind of get a feel for how it works, and you kind of like buy a few of those, and then you can go. So you can either put these together or you put in the collet and then the tool. Get it started. You see it fall down. And you put it in and you tighten. So the guy I mentored from had a 3/4 wrench up here, and that's what he used always. And he used it not only to tighten and loosen, but he also used it to hammer the end of the drawbar when the taper gets stuck. I don't do that. So you hold the brake and then you tighten. And then I've got the muscle memory habit of switching its direction, and then I put it on one of the bolts on the mill to hold it. So UPS just came and took our boxes. I'm going to shut the door and grab a chunk of cardboard and see if I can block off that light. Well, sort of. Okay. Oh, that's better. Yeah, so I'll probably move you in closer too. If you picked up a mill and you got it for free, there's a good chance it doesn't come with vise. They're pretty expensive. So see if you can find one used. They're hideously heavy. You're going to need it to hold down your parts. In mine, I have 2 pieces of T7 aluminum soft jaws and that I made. And then I've had those in there for 20 years. So every once in a while, maybe I'll wind them down a little bit. I don't know. Yeah, so you're going to want to get a vise. Research how to square your vise to the spindle. So it's like a setup thing. Everything can be changed, and that's great and horrible at the same time. These 4 screws right here affix the entire spindle to the arm, so you can rotate it. It's pretty heavy, so there's a screw here that you turn, and it applies force one way or the other. Lots of back and forth happens in the middle when you do that, like so as you cross the center of gravity. I know I'm a little bit off because if you cut one way and turn around and cut the other way in the same spot, you should get witness marks both directions. If one direction cuts and the other doesn't, then you're scalloping a little. Not all mills have this feature. I have 3 screws on the side, and it can tilt the head forward and backwards. A kind of cool thing is that lots of stuff is adjustable. So this is the spindle handle, and so you can pull it out a little bit on its detent and change its position. So like if you're working down here, then wherever you've got the height set, you want your handle to where you're controlling it. So yeah, you can just take it off and spin it around. This little dealie here is a lock. It locks the up and down travel of the spindle. And I'm kind of going in the level of newbie. You're going to need these things. So I'm skipping over knobs and stuff because that's fine. Don't worry. Your high versus low is something you're going to pay attention to. That's here. You push in the lever to move it. And then it will often not go into position, so then you turn it and then it will. Now for like kind of its first great magic trick is left and right. I changed out the normal handle you see on the far side for this round deal because my mentor had that on his Bridgeport and I got spoiled by it. Same for the vise. It didn't come with this 3-handle dealio. It just has this goofy, weird wrench thing. So you can go left and right, and that's your cross, I think crossfire, I don't know. You can go in and out. You have dials on here, almost always they are in thousandths of an inch, and typically one full revolution is going to be, is it 200? I can't be. Yeah, I guess it is. So that's 100, this will be 200. So like, I don't really pay attention, I just watch the digital readout, they call it a DRO. The next magic trick is the knee. So the fellow who I saw on the Book of Facing who had this, his knees handle was like laying on the table. So when you're not actively using it, I put it in backwards so that when I'm walking by, it doesn't hit my leg. And I think now it's time to bring you closer. Sorry if it's loud again. Okay, so that's the knee. And this raises the entirety of the table up and down. Left goes down. Each complete turn is a tenth of an inch. And so all of the dials have a lock, so you can loosen it and set your 0 and then tighten it. So you kind of have a foundation. But there's lots of ways you can screw yourself with that too, because where's 0 up and down? Because this is loose. Did you lock it? Did you have a 0 set? You start talking about making things accurate, and now you get into trouble. Lots of troubles. Can you see it down here is an oiler? Maybe I should just take you off of the arm. Can I take you off of the arm? Let's try that and see. You're on a GoPro mount, so it shouldn't be that hard. But you're not a GoPro, you're just a webcam. Just a webcam, not special. Or is it vomit cam? Okay, so this is the oiler. You're going to pull down this lever. Normally once. Every day you run it. You can buy what's called whey oil or whey lubricant to lubricate your wheys. So that was like first level of complexity. We're going to turn the monitor so I can see it. First level of complexity. Your motor is a 3-phase motor, so it's going to have wiring like any other 3-phase motor. And so 3-phase motors, you can Google that, or I'm probably going to do a little thing about that too. But it'll have high voltage and low voltage wiring. Honestly, it's not that incredibly special. If you've gotten a mill from somebody that works, it's probably set for low voltage. I have the NEMA plug that's got the 5 conductors. So we have X, Y, Z, neutral, and ground. So my 3 phases. A return if we do 115 and then ground. So in theory, I could put a little box on the side and then it could have like a normal outlet. Instead, I have this cheesy extension cord that's, I'm sure, against everything ever. Oh yeah, you can also loosen these bolts and rotate the whole thing. I'm sure there's reasons. Every time I've disturbed this, it has been to make a tool reach something too big to fit in here. So like I have aluminum molds, and those aluminum molds are pretty big. All the moving parts have locks. This is a lock. You pin it down and then it restricts the travel going up and down. This way's locks are here for left and right. And then you've got here for front to back. Oh, good, you could see what I was doing. Nice. What else have we got? So there's a power feed. Those are pretty popular. A lot of machinists use these, especially for production. You get it set up and you're doing a cross cut, and then you're gonna push it and it'll start going that direction. It locks in and it starts going, and you've got a little dial here for the speed. Mine broke about a year ago, and I honestly haven't missed it, so I haven't played with it. And then it has a rapid traverse button to like haul butt going across. There's a limit switch here, and it's set so that when this hits it, it just stops. Original old school power feeds have different slidey things. Just look up the part number, the nameplate of the model, get the PDF, read how to use it. The DRO is set up via glass slides. That's here. And there's another one mounted on the back of the table. And then those feed here. So a Mitutoyo is going to be probably $1,000, I think. Geez, it's been 20 years, literally. All right, so I'm going to put you back on the mount. We're going to do that. And none of my actually 4 subscribers are watching. It says I have 6, but I know there's 2 repeats. One of them is me. Okay. Sorry about the noise. All right, so let's play with it a little bit. First thing to do is you're going to get eye protection, which, you know, just to behave, I'm never one for safety equipment. But let me tell you what, I don't want to have hospital bills, and I'm really fussy, and I get grumpy if I can't see. So yeah, we do eyes because things break. And I think if we turn it to reverse, it'll make this tool on high speed turn the way we want to cut it. And it does. I've cheated and I have a variable speed, so I can just change the dial. I typically run between 600 and 900 RPM. You just don't need a lot of speed, especially with aluminum. Most of what I do is aluminum. It's so easy to work. It just doesn't care. So you go to stop, and there's a brake. You can instantly stop your tool. Now, we're going to talk about the cool thing about drilling is the quill feed. So it says out and in. You pull up the knob, turned on like a PTO in a truck. Now this knob is spinning. Maybe we can move you closer. Wouldn't that be useful? Okay, we're on my foot. Ow. Okay. Hey, you can tell it's spinning. Hey, look, it's spinning. So you throw this lever, and you have a power feed on the quill. This knob you do on the side has 3 speed options for how many thousandths down per revolution. If you're going to use this, pay some attention that you might wear out your tool faster because you're not paying attention to how it works. So on here, the quill, there's this little knob. That's a stop. It's like a work stop, and you can sit there and run that up, and you see it's got graduations on it. If you didn't buy a cheapy Chinese mill, this might even do something. People even mount not vernier, but digital calipers on here. There's like a special one that hooks into this, and it tells you what's happening. So instead of having that knob you can just get this little gizmo that clicks on. So a thing to do is you have your piece, and then so like, okay, here's our limit. We have our piece up here. I'm gonna use the lock, and then get this where I can touch it. So I'm like, okay, I know what's happening. If you're doing production, a lot of times you can have your part, you loosen it, change your part out, clamp it, bring your tool sort of close to what it's going to work, and then you throw the latch, and then you let it do its cut, and then come back up. So that's one way you can use this, but it's just a great thing for if you have to drill a whole bunch of holes. Buy yourself a couple drill bits from McMaster, get one for that material, McMaster.com. So that's kind of a neat gizmo. Other features we did not talk about. Oh, speed. Okay, so that's over here on the other side. You push the lever in and you rotate it around. The power feed does work in both speeds, but there's this, it's supposed to have a handle you can pull in or push out. You can't run it backwards, you can only run it pushing down. So now we do reverse, and it does that, and it is doing the right direction. So I forget what the magic deal with that is. Read a book. I don't ever use the in or out feature on that. I don't think I've ever used, maybe you would use power feed on low speed if you're doing like boring into aluminum, maybe. Probably not. Normally you're gonna do things where you set your zero, you clamp your part, and then you use the knee to bring the part up into the tool. I use low speed for steel or for really pissing people off, and I'll use it on a tap. I do a lot of metric tapping, and so I have fluted taps, spiral taps. And then so typically if your part's less than a ½ inch, you can get away with just driving it in, shutting it off, put it in neutral, and wind it out by hand. That's what I do. Put it back up here in high speed. So when you've got a mill and say you get it from somebody, a thing that can happen is that the ways get worn, and I think they call it a jib. You can tighten. Make sure we didn't drop you. And so this is called a way cover. It's a little accordion. So one of those is here, and you can tighten it, and it wedges against your dovetails so that you have a tighter fit. So you're never going to get rid of slot, but it can help make it predictable. It'll help the table from moving, like it won't move. So one of the ways it wears out is that. And so you get just a bunch of travel in the same spot, and then you get a little bit of wearing happening. Another thing that happens is if everybody clamps here or here all the time, and all your time is spent, you're gonna get a loose spot in your tool, like in your whole system. So the table has what's called T-slots, and these bolts go through. And so the weight covers help you from getting debris down into parts that move. So you can see some folks just don't ever clean their stuff. And if you do it right, you might lose tools in this too. Like, isn't that great? I do a lot of writing on here in Sharpie. For cutting food, I just use kerosene. So that wears out. Another thing that people are big about is that your machine must be level and it must be very stable. So don't put it on a broken pallet jack so that it's just movable. Because if you look at the ground, you can see this whole world moves around. So people are turning in their graves. Hey, guess what? I've seen no difference other than it makes flat spots on the plastic casters. For me, accuracy is like within a thou. Who cares? Honestly, we're not cutting glass here. We're not polishing lenses. If you want rocket science, you don't have a hobbyist mill. So yeah, I think that's sort of about it. So I also told him, like, this mill was in my garage for 6 years, and then it was hooked to a phase converter, so it did single phase to 3-phase cheating. That works fine. Like you'd run it. You'd run it, and it would just, instead of sort of instantly become running, it would take a second. No biggie. I could tell no real difference in the amateur cutting I do. Yeah, I make good chips, but at the same time, I'm not doing production. I've watched people do production. It's pretty hard on the equipment. It makes heat, it makes smoke. You have to rig air, you have to rig cooling. It can tear up your equipment a little more. You have to watch out for chatter. I mean, there's a lot of things that can go wrong, but if you're just, hey, I just inherited this mill, keep it, make it work, because there's no better drill press than a vertical mill. One time I used it to do a counter. Like, I needed something done, and I was like, screw it, let's throw it on the mill. So you can get accessories to set up and work on clamping and holding. So that's another subject, especially at McMaster. You can go into a vertical mill and look at fixtures, tooling, things for a mill. Like the speed work stop thing, I don't know what it is. When I bought this, I bought a lathe. I went to northerntool.com. They were pretty new. This was like in 1999. And I told the dude, hey, I've got 10 grand. Get me a mill and a lathe, a DRO, and all the shit I need to make a mess. And they did. So that worked out. Okay, I think that's about it. So hopefully it wasn't too hideously boring. Hopefully it was a little bit dorky. And don't forget, don't ever do anything I do and assume you'll be safe. I learned everything the hard way. Get a PDF, read a little bit, watch different YouTubes. I never want to be without my mill or my lathe ever again. If I need 2 holes this far apart, if I need something on center, it's just so handy to be able to even eyeball it and get it. Unlike a drill press, you actually can drag left and right, and you can dig a trench or face something down. it's one of those things where until you have one, you have no idea what you would use it for. And then once you get it, you don't know how you ever live without it. I use the mill to machine these holes. These are offset a little bit intentionally. I'm left-handed, so I wanted these to be a little closer to the middle, but also wanted the full width of clamping. So I think these are, I want to say they're a foot, and this is an 8-inch vise. I don't know. I just don't. Numbers 20 years ago. Yeah. I'm gonna take this out. So it gets to where you remember, you get the muscle memory of how to change spools. It's not that hard. One thing that is really great about drilling and tapping, even if you don't cheat and you just put it into neutral, you can turn this by hand. And once you've drilled your hole, you can put your tap up in there and get it started and have just incredibly great threads beginning, and then you can take it away and do by hand. If you're into SAE taps, I recommend not trusting the drill sizes on the chart or on the tap. It's just, metric stuff is so simple. I've done it, like I always did metric because I did jet bikes, and then holy crap, like I tried to do SAE, quarter 20, and the first time I started by hand, I just broke the tap. Never used it. So disappointed. So like metric is a lot more forgiving and friendly. Yeah, okay. Ramble. Thanks. I'm gonna save this and figure out where that group was and then post a link. So if there's more you want to know specifically, feel free to post it. If you have ideas and want me to redo it, I'll think about redoing it. Maybe not. I'm really not into editing. I have other things to do, like drink beer. Yeah. And definitely, just type in vertical mill safety. Like my mentor one time was just going to town on a part with the animal head. It had a five inserts, and it shot the part and it put a dent in the wall, and then it flew. So, it can get real. It can. Yeah. See ya. Bye.